use binary to solve for this multiplication, 15 times 3. Okay, so therefore what we can do is, one way we can write it as 15 times 2 to the power of 0, alright, plus 15 times 2 to the power of 1, and that's it. Alright, because 2 to the power of 0 is actually 1, 2 to the power of 1 is actually 2. Alright, so 1 plus 2 is actually equals to 3. So as you can see, this portion and this portion adds up to this portion, while I keep this constant. Correct? Then the other method is that I can also I can keep this constant. I can write as 3 times, alright, 2 to the power of 0 plus 3 times 2 to the power of 1 plus 3 times 2 to the power of 2 plus 3 times 2 to the power of 3. Alright, this is the longer method. So this thing over here is actually 1, 2 to the power of 1 is actually 2, 2 to the power of 2 is actually 4, 2 to the power of 3 is actually 8. So 8 plus 4 is 12, 12 plus 2 is 14, plus 1 is 15. So therefore your 15 can be represented by these 4 binaries. Alright, while your 3 is kept constant. You see? So I hope you get a feel of things already. Therefore, in order to let it sink into you quite readily, I'll use the longer method. Alright, so I can re-represent my 3 as a binary of what? I can write it as 0, 0, 1, 1. Correct? Maybe by a space bar. Okay? I think you know why, right? Because 2, this is 2 to the power of 1, this is 2 to the power of 0. So 2 is 2 plus 1 is equals to 3. Alright, so this 3 can be represented by this binary. Okay? So times 2 to the power of 0, simply I didn't move anything. The 0, 0, 1, 1 is still here. Alright? Plus, alright, over here is 0, 0, 1, 1. I'll just copy and paste it over here. Times 2 to the power of 1. Okay? And therefore what I can do is simply to shift it one step, because it's 2 to the power of 1. Alright, so I shift it one step, I add it 1 0 over here. Okay, and that's it. So this is it. Alright, next thing, I have 3 times 2 to the power of 2. Right? This means that I'm gonna shift it up by 2. So I shift it 1, I shift it 2. Alright. Behind I add in 2 zeros. Okay, so likewise for the to the power of 3, I shift it 3 times. So I have 1, 2, 3. Okay, so behind I add in another 2 zeros. Okay, I hope you kind of get what I'm trying to do, right? So I can also bring this closer, because we didn't do anything yet, because 2 to the power of 0 is nothing, or we didn't shift anything at all. Alright, and then you can evaluate your stuff by simply adding up stuff. Okay, so I'm not go through this part, or maybe never mind, let's go through. So 1 1 0 0 0, I add with 1 1 0 0, I will have what? Or maybe I should add this and this first. Okay, so 0 0 1 1 plus 0 1 1 0. I will have 1 plus 1 is 0 bringing 1, so 1 plus 1 is 0 bringing 1. I have 1. So this part is 1 0 0 1. Okay, so 1 0 1 plus this one is 1 1 0 0. I will have this thing. This is 0. This is 1. 1 plus 1 is 0. Bring forward 1. So I have 1 0 1 0 1. Alright. So this whole thing over here is 1 0 1 0 1. Alright. And now I'm gonna plus with this one. Okay, so I have 1 0 1 1 0 1. Okay. So if you want to evaluate this thing over 15 times 3 is 45. Okay, I can actually compare this. So this is 2 to the power of 5. So 1 times 2 to the power of 5 is 2 to the power of 5. And then 0 times 2 to the power of 4 is 0. Plus 2 times 2 to the power of 3 to the power times 1 is actually 2 to the power of 3. and then plus 2 to the power of square plus 2 to the power of 0. This thing times 0 is still 0 lah. Okay, so 2 to the power of 5 is actually 32 plus this is 8. Alright, plus this is 4 plus this is 1. So 32 plus 8 is 40. 40 plus 4 is 44. 44 plus 1 is equals to 45. You see, we have 45. Okay, so I hope that this is pretty clear for you. Use binary to solve for this division, 15 divided by 3. Okay, so what can we do? Alright, this is very unfamiliar. That's why I want to do this exercise. Alright, so 15 divided by 3, I can actually split it out. Alright, so what I can have is that I have 15 divided by 2 to the power of 0 plus 15 divided by 2 to the power of 1. Alright, 2 to the power of 0 is actually 1, 2 to the power of 1 is actually 2, so 1 plus 2 is actually 3. So I keep the 15 constant now, you see, or I evaluate the 3 as a binary. Alright, so now over here I can change this 15 into a binary also. So this 15 over here, what can it be? Alright, this 15 can be represented by it's 1, 1, 1, 1. Alright, so 8 plus 4 plus 2 plus 1. So 8 plus 4 plus 2 plus 1 is 15. Right, you can check it out. 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. Right, so I can rewrite as 1, 1, 1, 1 divided by 2 to the power of 0 is divided by nothing. So this thing never shift anywhere. Plus 15 divided by 2 to the power of 1. Alright, so 1, 1, 1, 1 has to be shift. Alright, this thing cannot shift anywhere already. Right? Therefore, we have a problem. Alright? And also, that 15 divided by 2 plus 15 divided by 2 to the power of 1 isn't an answer. Because 15 divided by 2 15 divided by 2 to the power of 0 is actually 15. Alright? Plus 15 divided by 2 is actually 7.5. So 15 plus 7.5 isn't 15 divided by 3. Alright? So the whole setup of the equation is actually wrong. Alright? And this is something I also want to tell you. Alright, so therefore in the division, you cannot use the method that we have done. Alright? And then what can we do? So this 15 I can write in terms of a binary. I can write as 1, 1, 1, 1. Can write divided by, alright, 3 is actually 0, 0, 0, 1, 1. Correct? So therefore, I can use this method to do. So what I can do is actually to write 1 over, how should I write? So this is a 4-bit, this is a 4-bit. I can write it as 1 over here. So 1 times 0 1 times 0, 0, 1, 1 is over here. So I can minus. So 1 minus 1 is actually 0. Is it? Let me see. You also get a wrong answer because this thing this thing minus each other, you'll get 0, 0, 1, 1, which is equals to 12, which is the wrong answer. Alright, so what can we do? Alright, it's pretty much simple. Is that you're going to write in terms of this thing. Instead of 0, 0, 1, 1, you write as 1, 1. Okay? And it happens that if it's a 0, 1, 0, 1, then you just write as 1, 0, 1. Okay? Ignore the highest order of the binary. Just take it as 1, 1. So if I were to evaluate, I will have 1 times 1, 1. I will have 0, 0. I have this thing over here. Alright. I'll have 1, 1. So 0, 0 minus 1, 1 is what? Alright. This 0 minus 1, I'm gonna borrow a 1 from somewhere. Alright, so therefore I'm gonna borrow a 1 from here. But this have no 1, so you're gonna borrow another 1 from here. So over here he'll take in 1 and then he'll give it to here. Alright, so over here I have 1. So 1 minus 1 is 0. So 0 minus 1, I'm gonna borrow again. So I'm gonna borrow another 1. So I'm gonna borrow another 1. So 1 minus 1 is 0. So I have 1, 1, 0, 0 over here. Okay? And then after that, let me see, okay, my fault. Then the second one, 1 times 1 1 will be over here. Okay, so oh, I get it. So now over here, alright, this is 0. I no need to do anything. I'll just put it as 0 because 0 times 1 1 is 0, so it will still continue to be 0, but I need to evaluate this portion over here. So in order to evaluate this portion, I need to multiply by 1. Alright, so 1 times 1 1, I will have 1 1 over here. Okay, maybe I should drag it all the way down. So I have 1 1 over here. So 1 1 minus 1 1 is 0 0. Okay, so over here at this top is actually 0 1 0 1. Okay, and therefore it is equals to 5. I know it's a bit rough, but at least something lah. So I think I can repeat again. Alright, since I think I'll just do it for my own self lah. This video will be myself already because it's not a good video lah. But anyway, this one is 11. I mean 1 1, right? So over here you can only minus with this part. Alright, so I'll just take as 1, because over here is 0, you have 1 1 over here. You get me? Because 0 times, for example, if you have 1 over here, 1 times 1 1 is actually this part. Alright, so this thing over here corresponds to this thing. Alright, this thing over here corresponds to these two things. Alright, this thing over here corresponds to these three things. Alright, this thing over here corresponds to these four things. Alright, so normally when you have something like a 3 over here, you have 0 0 1 1, don't straight away plug it in and 0 0 1 1. Alright, this is something that you need to understand. Okay, so if you have 0 0 1 1, take in the last digit and place it here. Okay, please be mindful of that. So I have, in this case, I have 2 digits, so I'll start off from the second digit. So 1 times 1 1 is 1 1. They cancel each other. Okay, over here, this is this digit. So this part over here, or this part over here, is going to talk about these 3 digits. You know that this is 0 0 1. Definitely you cannot have a 1 over here. So 1 times 1 1 is actually 1 1. Right? Cannot be, right? So you can't evaluate in this manner. So therefore you need to know that over here you set it as 0, and over here 1 times 1 1 is for this portion over here. Right? Because this portion has already become 0. You see? So this is a bit something that you need to understand. Alright, this is the part I think is pretty confusing. But once you clear this part, I think it's pretty cool. So 1 times 1 1 is 1 1. So they cancel each other, is 0 0. So remainders are zeros. This thing over here is 0 1 0 1, which is equals to 5. Okay, so I think this is it for the practice question. So see you soon.